A very good morning, good afternoon, good evening to all the participants and candidates for this MOOC-NPTEL course, the title of which is Application of Forecasting, Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. And the three main topics which we basically cover in this course are averaging techniques and forecasting, which we are now going through. Second one is multiple linear regression, which will be covered the next, and the last part would be the ideas and detailed discussion with examples for time series analysis. This is the topic which we are going through. So, hence the slide shows accordingly, and this slide basically shows which week and which lecture number. So, we are in week 2 lecture number 7, which is the second lecture for week 2. What is the coverage? So, coverage for this lecture here we will try to cover. Obviously, as I said, the lectures and slides are updated depending on what is the coverage, and if there is any spillover, it is converted to the next and carried for the next class or lecture. The coverage for this lecture is examples of forecasting. We will consider that and highlighting the different matrix which we have discussed in the last class was about mean absolute error, mean error, then percentage error, absolute percentage error, U-statistics, and how they are utilized in order to analyze a forecasting model. And also remember, we had also mentioned when we were discussing about AIC, Akakai's information criteria, we said that there are different type of metric which is applicable for different type of examples. So, one metric is not the solution for all the problems. Remember that, and we will highlight that with examples. We will consider the concept of interval estimation using simple diagrams, and why that is important we will come to that later. We will consider what is tolerance interval, what is the prediction interval, and the distribution of the errors is also very important, which we will analyze using actual data from one example. We will plot it and then try to analyze the results of that, and later on use those concepts of the metric and finding of the error later on in different examples. Continuing the discussion about forecasting and U-statistics which we were discussing, U-statistics incorporates both the MAPE, which is mean absolute percentage error, and the naive concept. Now, if I consider the naive concept very simply, it is like this. Say for example, the actual values I will denote by y t, and f t is basically the forecasted value. I am using the same color. Now, under the naive concept, if the forecasted value f t is there, then the best concept of trying to basically predict the actual value for the next time period, which would be here. The expected value of f t would be the best predictor of y t plus 1, which means the forecasted value of today would give you the maximum information for the actual value for 1 day later. Again, I am mentioning the time frame as 1 day. It can be depending on the idea or the problem, it can be for week, month, seconds, quarters, and half year, 1 year. But when the example continues, I will continue using the concept of 1 day. That means, y1, y2, y3, y4 would correspond to day 1, day 2, day 3, and so on. Now, this is basically the idea of the naive concept. U value is 1 if only if the factor. So, if you see in the concept of the U statistics, there was a ratio, square root of a ratio, and the ratio was basically in the numerator you had the square of a term, in the denominator you also had the square of a term. And if you remember, we were utilizing the concept that in the U statistics the numerator and denominator were with respect to the decimal change, or say for example, the percentage change of the difference between the forecasted value and the actual value divided by the today's forecasted value. And in another case is basically the difference of the actual value for tomorrow minus that of today divided by the actual value for today. So, in the denominator in both the cases of for the U statistics, it remains as YT, and the numerator for both the numerator and the denominator. That means, when I am talking of the U statistic, there are two terms. One is the numerator and one is the denominator. Now, when I consider the numerator, the denominator of the numerator is YT. Similarly, the denominator of the denominator is YT. The only change is the numerator of the numerator and the numerator of the denominator are the difference corresponding to Ft plus 1 minus Yt plus 1 in one case, and another case is Yt plus 1 minus Yt. Oh, my mistake, it should be Ft plus 1 minus Yt. So, that we will see later on as we consider. So, U value is 1 only if the FPE t plus 1 is 0, and that would occur if the errors in the forecasting methods were the same as those that would be obtained by forecasting no change at all in the actual values, which is comparable to the naive value concept, because in the sense that the naive value will consider whatever has been forecasted today, there is no change, and that would basically be the actual value for one day later on. Hence, expected value of Ft is equal to the actual value of Yt plus 1. If U is 1, so now U statistic will be categorized into three different concepts. One is where U statistic value is 1, one case in when the U statistic value is less than 1, and the third case is U statistics value is greater than 1. If U is 1, naive method is as good as the forecasting technique being evaluated. So, we will be more than happy or more than confident to consider the naive concept as the best predicting concept idea depending on the value if it is about 1. If U is less than 1, forecasting technique being used is better than the naive method, and hence smaller the U statistic, the better the forecasting technique is relative to the main naive method. So, obviously, there is no lower bound. So, I am say for example, if the values is 0.5, in that case the U statistics forecasting concept which you are using, based on which you are using, would basically give you much better results than the naive method. If U value is greater than 1, there is no point in using a formal forecasting method, since using a naive method will produce better results. So, again I am repeating, U is 1, forecasting method and the naive method are exactly going to give the same result. If U is less than 1, then the forecasting method gives you better result than the naive method, and if U value is greater than 1, then obviously it makes much sense, better sense to use the naive method and not use the forecasting method. Now, that forecasting method is the one which you are going to utilize, and we will come to that one by one. So, this is an example we are going to use and utilize that to find out the U statistics. So, the data set which you have, I will mark as the first column, which is time period t. The second column is basically Yt, which is the actual value. The third column is basically the forecasted value, which is Ft, and correspondingly you have the fourth column and the fifth column. So, what is the fourth column? If you remember in the U statistic, when you find out the square root, there is a term in the numerator and the term in the denominator. We are basically utilizing that. So, here in the fourth column is basically you are trying to find out the difference between the forecasted value for tomorrow minus the actual value of tomorrow divided by the actual value of today, and squaring it up as we have mentioned. While in the fifth column is basically the difference between the actual value for tomorrow minus the actual value of today divided by the actual value of today. So, again the only difference is this, which I will highlight using the red color, and I will remove that once it is done. So, here you are using Ft plus 1, while in this case you are using yt plus 1. That is the only difference. So, here you have the time period 1 to 8. I am only considering 8 time periods. The yt values are given starting from 138 to 153. The forecasted value I am considering they are there, because how we find out we will come to that later, but considering it is given, we will try to utilize what are the metric and which gives the better results and which forecasting technique to use or which metric to use. FT values are given starting from 150.25 to 141.5, and here we take the values accordingly. So, in the first case, if you remember, if it is FT plus 1 minus YT plus 1. So, the FT plus 1 in this case is basically 139.5, because you are going one period forward, and 136 is basically the value of yt plus 1. So, basically that goes in the second term as the numerator, divided by 138. What is 138? If you remember, 138 is basically yt. So, here it comes as yt. So, finding out the ratio of ft plus 1 minus yt plus 1 divided by yt, squaring it gives you the value of 6 to the power 10 to the power minus 4. So, this is the value. Similarly, if I go for the next value, in that case it will be, if I follow it, I will use the red color only to black color to do the calculations. I will write down now for the value which is given as 15 into 10 to the power minus 4. The value would technically be 152, which is yt plus 1. This would be this would come later on, sorry. So, it will basically be 157.25, which is yt plus 1 minus 152, which is fyt plus 1, ft plus 1 minus yt plus 1, divided by the value of 136, which is yt, squaring it, and that value will come out to be 15 into 10 to the power minus 4. So, if I continue doing it, consider for the 7th value which you have. So, I will use the color, say for example, dark blue to do the calculation. So, here it will be 141.50, which is ft plus 1 minus yt plus 1 would basically be 153 divided by yt would be 119, squaring that will give you a value of 93 into 10 to the power minus 4. So, considering that I do all the values, I have the fourth column filled up, and the sum of the fourth column is given here is 0.0559, which will come in the numerator of the U-statistic. So, having said that, we will erase all the values which the calculation which we have shown or highlighted for the fourth column, which was the numerator of the U-statistic. Now, we go to the calculation using the same coloring schemes as far as possible. So, the values are, the concept is yt plus 1 minus yt. So, if I consider yt plus 1, so the value is basically 136 minus yt, which is 138 divided by 1 yt, which is again 138. So, that value comes out to be, for the first value comes out to be basically 2 into 10 to the power minus 4. So, if I do that calculation, say for example for the fourth row, the fourth row value would be, in this case, would be 1. Let me change the color. So, I will use the red, use the violet color. So, this would be 151, because that is equal to y t plus 1 minus 127, which is y t, divided by 127 square of that. That would basically give us the value as calculated. So, that will give me, if I recall, and I am just to highlight, that will give me the value of this one, 0.0105. I would request all the candidates or the participants to double check that. If I go to the last value, which is here, I will use the say for example, the orange color. So, the calculation would be 153, which is y t plus 1 minus 119, which is y t divided by 119, square of that will give me the value of 93 into 10 to the power minus 4. So, once I again write out all the values, do the calculations, find out the sum comes out to be is 0.1849, which will go in as in the denominator for the U statistics. Putting these values in U statistics, which is square root of 0.0559 divided by 0.1849, that value comes out to be 0.54, which I am highlighting here, which means that if you see U being 1 means both the forecasting technique and the name method were almost the same. If U value is less than 1, which means that the forecasting technique is being utilized is better than the naive concept, and U statistic being greater than 1, it means the naive method is much better than the forecasting concept which you are using. So, considering that U statistics is about 0.598, we would be more than willing to utilize the forecasting technique which we are using. What forecasting technique we are using, we will come to that later as we solve the problem. Here, the main point is that the relevance of the U statistic and when the forecasting concept which you are using is better than the name method, or the name method is better than the forecasting technique. So, that was the discussion what we did for the last 5 minutes. Now, we will consider the concept of autocorrelation function. We have already discussed that. We are considering the autocovariance, we are considering the autocorrelation function, we have considered the correlogram diagram, but we will consider more of this in simple examples. Autocorrelation function of the one step forecast error is very useful in determining if there is any remaining pattern in the errors or in residuals after a forecasting method has been applied. So, if you have applied, you want to find out whether the autocorrelation concept and the values are there, and based on those values, we will be much more confident in trying to say whether the forecasting technique which you are using is really a good one, and we are more than confident in trying to utilize those forecasting technique. This autocorrelation function is not a measure per se, but rather can be utilized to indicate if the forecasting method could be improved, in the sense whether the model, depending on the parameters which are being utilized, they should be changed in order to improve the efficacy of the model. It is good to have a benchmark to determine if an autocorrelation is significantly large, and a simple rule is to only consider autocorrelations that are larger than the critical values of given here, which is the ratio of 2 by square root of n, where n is basically the number of readings which you have. So, depending on the critical value, you can decide whether the autocorrelation functions are important, and based on that, whether the model which you are utilizing can be improved depending on the change of the parameters, and why we change the parameters would definitely depend on the metric which you are trying to find, or trying to basically find out the error. And what is the error, concept of error, I keep saying it can change depending on the example, we will see that later on. Now, coming to the concept of interval estimation, and we will utilize a diagram. By the way, we would not be going to details, but we will just highlight the concept that how the interval estimation would make relevance when you are trying to find out the forecasting point. because interval estimation would give you some idea about the errors or the variance or the standard deviation. But one thing should be remembered, that the variability or the errors or the standard deviation we are talking about is not for the normal distribution only. Why the word normal distribution being used? We will see that in due course of time. In statistics, interval estimation is the use of sample data to estimate an interval of possible values of a parameter of interest. So, obviously, when there is a parameter which is fixed from the population, that is fixed, it does not change. But when we are picking up a sample from that population and trying to estimate the value of the parameter, so obviously for each sample the estimate of the parameter will change. So, if you remember, if you have done the DADM1 course, which is data analysis and decision making, one very important concept which was discussed for the estimates are: point 1 is basically the estimate should be unbiased, which means the expected value of the estimate in the long run should be equal to the actual parameter value. Number 2 is basically consistency, in the sense the variability of the estimate based on the sample size which you are taking, it should slowly decrease as you increase the sample size. So, the concept of unbiasedness and variability is very important and should be remembered. That is two of the fundamental characteristics any estimate should have about the parameter based on which you are trying to find out that what is the best estimate. Now, in contrast to point estimation, it gives you only a single value which we are trying to do, but for the interval estimation it gives you the range. So, the middle value based on which you are trying to find out the range is considered the basically the estimated value, which in the sense that if you are considering the idea of unbiasedness, it should be the expected value, while the interval will give you so called variability based on which you are trying to find out that how consistent your answer is. The most relevant forms of interval estimations are confidence interval, and confidence interval basically depends on the level of confidence. It can be basically based on 90%, 95%, 87%, 85%, but that would depend on the level of confidence you want to basically keep for the estimate based on the sample you are trying to utilize. The confidence interval is basically based on the idea of a frequentist method, while the credible intervals is basically based on the Bayesian method. We would not go into the details of the ideas based on the frequentist method or the Bayesian method and not trying to compare them, but we will try to basically give a very simple diagram in order to highlight the idea of the confidence interval. Other forms of statistical interval include tolerance interval. So, the idea of tolerance interval, even though not very applicable here, is that if you have done the total quality management course, which is one of the course which I teach in NPTEL, there the idea of tolerance, the upper control limit, lower control limit, what is the tolerance level depending on the range, depending on the standard, on the mean of the sample, those ideas are heavily utilized and extensively utilized in quality control. So, the tolerance interval is basically means to what level you are able to basically change the value or take the sample in such a way that the fluctuation of the estimate is permissible. So, which basically other forms, let me read it. Other forms of statistical interval include tolerance interval covering a proportion of a sample population, and prediction intervals, which is an estimate of future observation used mainly in regression analysis, which we will see. So, prediction interval basically would mean that when you are trying to predict the actual value of the independent based on the independent variables x's, you are trying to basically find out the dependent variable. So, dependent variable obviously would have some fluctuation depending on the data set, depending on the error. So, you want to find out that what is the prediction interval based on which you can say whether the predicted value is consistent, and also you will be interested to find out whether the predicted value is also based on the idea of unbiasedness. So, this is the diagram which we have, and let me spend some time here. So, if you see, there are 3 diagrams and the coloring scheme has been done accordingly such that there is no confusion for us. So, the blue one which you see, I am not going to mark it immediately here, but I am just hovering the stylus. So, this blue interval is basically the diagram is for the normal distribution. Mean value is given here, and the mean value is about 6. Now, if I consider the two distribution, one is skewed to the right, one is skewed to the left, and the distributions are given by the orange one, this one for the first one, and the mean value is shifted to the right with respect to the blue one. So, mean value is shown by the vertical line, vertical arrow, while the other distribution which is skewed just opposite is highlighted using the red color. Again, I am just hovering the stylus without marking it, and the mean value of that distribution is more to the left with respect to the blue one. It is about 4.95. I am giving you some approximate value. By the way, for the one which is more tilted to the right, it is given by a mean value with which is approximately about 8. Consider 8 or 7.5. Now, what is the interesting thing? If you see, I have drawn two intervals which are shown by the red vertical lines, and the intervals basically means that with respect to the normal distribution, if I find out the area between the intervals, it is equally dispersed both above the mean and below the mean, considering normal distribution is symmetric with respect to the mean, median, mode. So, let me highlight it using the light blue color. So, if I consider the mean for the, I will only highlight the area. So, I will just highlighting the area. Considering the normal distribution is true and the interval is given by the red vertical line. So, I have to basically erase the area of the blue line when we consider the other two distributions which are marked by red and orange. Red means dark red. So, I will spend some time in order to highlight. So, this is the area which we have between the two vertical red lines depending on the interval which you are trying to predict. Remember, for the normal case, the intervals are, again I am repeating, they are equally dispersed above the mean and below the mean. And interestingly, for the normal distribution, the mean, median, modes are exactly the same, which is one of very unique property for the normal distribution. So, if I basically mark the area, so this is the area which I have, and consider this is equally dispersed. But if I consider the red line and I remove all this part which was highlighted using the blue one, and if I only concentrate on the one which is skewed onto the right using the orange, then the area between these red vertical lines so, this area is totally different from the blue one which we have seen. If you go back and you see the video, it will become so. The area is different, even if the total coverage you are trying to cover based on the normal distribution for which the mean being mean, median, mode being the central value is equally dispersed. Now, if I consider the one distribution which is more onto the left, and I will basically highlight that using the red one. So, if you see it here, interestingly, I will use the other slanted one. So, again the red one is totally different in the area with respect to the orange one, and which is also different with respect to the blue one. So, the interval which you are going to find based on the average value. So, the average value for the first one is about, let me write out, about 4.5. The average value considering the normal distribution is about 6. So, I am using the coloring scheme. So, there is no confusion, and for the one it is basically about, for the one which is on to the right is about 8.5. So, based on that, when we consider, you find out the intervals different. So, we will come to that later on in discussion, but the main idea is for the forecasting concept is to find out the estimate using one unique value, which is basically the idea of point estimation. And if I consider the standard deviation based on the point estimation, you can find out the intervals accordingly. So, again I am repeating, our main emphasis would be to find out the point estimate and utilize the metric as we seen, the U-statistic, mean squared error, mean absolute error, then the percentage error, absolute percentage error, and try to basically predict which model would be the best considering the different type of ideas we have, and then try to compare, consider that we are utilizing the name model, and see that in many of the cases one model may not fit all the data set. This I am repeating time and again, you will see that with simple examples. With this, I will end the second class for week 2 and continue discussion further on. Thank you very much and have a nice day.